on? Number one.
Number one.
Okay.
Number 15.
So if this is greater than 1, what do we know? It converges. Do we know what it converges to?
No.
No, but we can find it, right? If it's less than 1 or equal to 1, then we can say automatically that it what? Diverges. So if this was a multiple choice problem, one of the answer choices was diverges, right? We recognize it in that pattern and the P is less than 1, boom, we're done. We just circle diverges, we're done. We don't have to show work, right? Okay. If it says converges, then it's going to say converges to, and it'll have maybe different numbers, and you have to find out which one it is. Now, there's a certain case, okay, if A equals 1, so if we get lucky and they go from 1 to infinity, okay, and obviously it has to converge, so for it to converge, P has to be what? Greater than 1, which is the instances that we did right before this example, or this notes, right? We did 3, where A was 1 and P was greater than 1. Then we can say the integral from 1 to infinity of 1 over x to the p dx, okay, not only converges, because it satisfies this, but converges towards a specific number, and we can find that number by doing 1 over p minus 1. So if I only know the power when I'm starting, right? I know what the answer is going to be by doing 1 over p minus 1. So let's go back and see if it works from. Okay. What was the power here? 3 over 2? What's 3 over 2 minus 1? 0.5. 1 over 1/2? It's 2, right? Or you can just do the subtraction and then get the what of it?
Inverse.
Yeah, get the reciprocal of it, right? Okay, so do it here. 2 minus 1? 1 over 1? 3 minus 1? 2. Flip it? 1 over 2. Easy?
Yeah.
So that was kind of hard to figure out, right? You're just kind of like, how was I supposed to know? I was supposed to subtract 1, sir. But some kid in the other block figured it out. It's pretty amazing.
Who was it?
Who was it?
Yeah.
It was Frank.
Oh. I was like,
Here he is.
Jesus.
Alright, so we did some examples?
Yeah.
Yes? See if you can recognize if they fit this form, and if they fit the form, we can go straight to the answer. Okay? So for all of these problems, I want you to tell me if they converge, and if they do converge, to what number, and if they don't, tell me that they diverge, okay? That's how you would write your answer. Converges towards what, or just diverges? Easy? Alright, so let's do some examples here. Ready? Let's see how fast you are. So the integral from 1 to infinity, we're starting at a equals 1, right? Of 1 over x to the 2/3 dx. What could you tell me about this guy? He diverges? Okay, why does he diverge? Diverges because p equals 2/3, which is less than or equal to what?
1.
Awesome. What would he diverge to? What would we put there? Infinity, right? We're still above the x-axis, except that we're getting closer to the x-axis. Oh no, we're getting closer to the x-axis, but not what? Not fast enough. We're getting closer to the x-axis slower than we were getting closer to the x-axis when it was a what?
1.
A 1. So if it diverged at 1, and this is smaller than him, then he's also going to what? Diverge, right? If that guy was stronger than me, and he couldn't do it, then I can't do it either, right? Yes or no? Yeah? Alright, cool. So, another one? The integral from 1 to infinity of 1 over x to the 1.1 dx. Yeah. What's this guy going to do? He converges for sure?
Yes.
Okay, can we figure out what he converges to right away? How can we figure out what he converges to right away?
You take the number minus 1 and then do the reciprocal.
Okay, why can I do that?
Because it's going from.
Because
Because
greater than one.
Because A is 1, right? So remember that, okay? Because it might be tricky and go from 5 to that and then mess you up. If it's from 5 to there, all we can say is that it what? Converges. We have to do the actual math to figure out what it converges. Okay? So this one's going to converge to, let's figure it out, right? So 1 over 1.1 minus 1. What's 1.1 minus 1? 0.1, right? What's 0.1 as a fraction? 1 over 10, so we get the reciprocal of that, which is 10. So he converges to 10. Easy? How about this guy? The integral from 1 to infinity of x to the negative 7 dx. Converge or diverge? Quick!
Something.
Come on, hurry! Converge or diverge? Diverge?
Converge.
Converge?
Converge.
Why does he converge?
It's 1 over 7.
1 over x to the 7. Ooh, they pulled a fast one on you. Gotcha! So this is the same as 1 over x to the 7, right? He's a p series. And is p greater than 1? Yeah, so he converges. Are we starting at 1?
Yeah.
So can we figure out what he converges to really quickly?
Yeah.
Yes? Alright, let's do it. Converges to 1 over 7 minus 1, which is 1 over 6. Is that a very small amount of space? Yeah, because he's getting close to the x-axis, what? Really, really, really fast. That number on the bottom is getting closer to being up. I mean, is becoming a bigger number faster. So that makes the whole fraction become smaller faster. Yes, no, maybe so? Woo. Another one. So the integral from 1 to infinity of 3x to the negative 3 over 2 dx. Uh-oh.
Wait a minute.
Is this a p series?
Yes.
Yes?
No, you can take the 3
No, it's
out,
not.
right? No.
Take the 3 out?
Okay. Yes.
Of course, you want to. So 3 times the integral from 1 to infinity, okay, look it up.
Now.
1 over x.
1 over x
1/2.
to the 3/2. So it is a p series? Okay, cool. Now is p greater than or equal to 1? Remember, p depends on 1, number 1. Right?
Greater than.
So he's greater than, so we're good? Yeah, alright. So, can we use the shortcut?
Yeah, we got 2 on the other one.
You got 2?
That's why.
Well, didn't we do it like that?
We already did this one?
Yeah, but it's times 3, so it's.
So it's 6.
Where, when did we do that one?
It was the first one.
Oh, we did it over here? So what do we get for it?
7.
2, right? So this is gonna end up being 2 times what?
3.
The 3, so now we end up with
Number G.
6. So he converges to 6. Awesome. So what do you think? What does the 3 do to him?
Makes it slower. Makes it go slower. Just kidding, I
Does it
don't
go
know.
slower?
No, like, makes the top bigger, but
What does that 3 do to the graph? It's a transformation. I don't know if you guys remember when
no.
Yeah, it is making.
when you multiply the y by something greater than 1.
Because the smaller number is that's your equation.
right, makes it like the one.
It's like stretching it out.
Stretching it, right? But how is it stretching?
3 to the right. I'm just kidding.
I have more space than I did earlier, right?
Yeah.
So that means it has to what?
Oh, it's like move down.
Oh, wait, no, it's vertical or a horizontal?
Horizontal.
Horizontal?
Pretty sure. No, if it's going down in 3, so we can't not go down as fast. When it's being
So that's the like shit.
Being shrunk horizontally? Sure.
You're like picking it up.
Is it being stretched vertically?
I'd say
What about
What if I stretch it vertically? Like, would it like pull that curve that we originally have kind of up?
Yeah.
Yes, that's what
Give it some more space there?
Wait, where'd you get that from?
Yes.
Hmm, interesting. Okay,
Okay, can you go back to the green part?
go back to the green part, yes. Green means go. No! Right. Are we good?
Yes.
So now those are only special cases if you can recognize that the problem is written in that form, right? If it's not, can we still work it out though? Yeah, we know how to work it out, right? Now, these get even more fun when, in order to integrate it, you have to do what?
Derive it.
Integration by parts, right?
Oh.
Yes! Or what?
Partial fraction.
Partial fraction! Awesome, right?
Yeah.
Or you sub, right? Woo! How exciting! So, should we do some of those, or are you okay without doing that?
Can we come out
Ready for the assignment? Ready for the assignment? They're not all gonna be B series on the
No, we'll do
assignment.
tomorrow.
Ah.
We'll do Tuesday, we'll do
We
Tuesday.
do an example?
Yeah.
Yes.
Let's do it. We haven't done one where the infinity's on the bottom, so maybe we should do one of those. Let's do one of those. So the integral from negative infinity, to zero,
No, yeah,
yeah, of 1 over the square root
Oh.
of 3 minus x.
That's not.
Is it an improper integral?
Yeah.
Yeah, it's got an infinity there, right? How do we handle him? Nope. Limit notation, right? We have to say we want the limit as what?
No, A.
A goes to what?
Negative infinity.
Negative infinity of the integral
Of A to B.
a to 0.
0, come on.
How can we rewrite this guy to make him a little easier to integrate?
3 minus 6.
3 minus x to the negative 1/2?
Yeah.
Yeah. Orderly. Now we gotta do some integration in our head. Can we integrate this guy?
Yes. We can.
Do we have the license?
Yeah.
This would be u, right?
Yes.
What would be his derivative?
Negative 1.
-1. Oh, we don't have a license. But give him a permit, right? So we have to add what to our answer?
Negative.
A negative, right? Good? Yes? No? Maybe so? So we know we're gonna have to add a negative. And now we're gonna think of him as u to the half, u to the negative half. So what would it be?
It would be 2.
U to the positive half, right? Times 2?
2.
So we're gonna have negative 2, add the parentheses, right? And then we're gonna have 3 minus x to the what? Positive half? Evaluated from a to 0. And we want the what of all that?
The limit.
Limit as a goes to negative infinity. Are you with me or no?
Yes.
Leave a space between the constant and the other part so you can put that parentheses there. You can throw that constant out. Does that make sense? Alright, so now let's evaluate the integral. Plug in 0. 3 minus 0? 3, square root of 3, right?
Yeah.
Minus. Plug in a. 3 minus a? 3 minus a. But we want the square root of that, right? And now we want the what of all this? The limit, right? And this is only gonna affect, we're gonna get the limit as a goes to negative infinity, and we're gonna focus on that part, right? Okay, so that's in our head, plug in negative infinity. 3 minus negative infinity, positive infinity, right? 3 plus infinity, infinity, square root of infinity, perfect square, infinity, right?
Nice.
So square root of 3 minus infinity,
Negative infinity.
negative infinity now, right? Because we're subtracting it. And then negative infinity times negative 2, positive infinity.
So it's divergent.
So this would be a function that what? Diverges. So if we think about the bounded space is going to accumulate what? indefinitely, right? It's gonna keep growing, right? So because that space keeps growing infinitely or indefinitely, it's gonna end up being some infinity. Cool?
Yeah.
Yes, no, maybe so? Was that easy?
Yes.
The hard part was the integrating, right? Okay, that's why we've done a lot of integration, right? Do a lot of integration in AB, a lot of integration here. Cool? Another one, or we're okay? You want one where we have to do like integration by parts, or no?
Yes.
We don't have enough time for
We have
it.
enough time, sir.
We wanna do an easy one.
Nah, do integration before.
It's still hard.
So we get it, homework, then we get it.
You want an integration by parts one?
Yeah.
Alright, let's do it. I don't think it's gonna fit here. I'm gonna do it in the back.
Just use formula.
Ready? Let's do it quick.
Where does go?
Ready? So what example is this, 4?
Yeah.
So let's do the integral from negative infinity to 0 of x e to the x dx.
How about that method?
So improper integral, set up your limit. What's it gonna be?
That method.
Limit,
A
a approaches
negative